Good morning. My name is Aravindh, working as assistant professor in the Department of Computer Science and Engineering. I'm going to take a video lecture on a subject computer networks. Under the computer networks, it's a very important topic called as OSI reference model. What in the OSI reference model means? Open system interconnection. Open system interconnection. I just want to send a data from a source machine to the destination machine. How this layer will help. Okay. First, I want to migrate a data from a source to the destination machine. First, I need a sender machine, a receiver machine, and then your media protocol, and then your message. So the first comes is your the system one. You just imagine as a sender machine, and system two will be your destination machine. So the source and the destination machine, and then the media is nothing but your by we are going to transmit the data using a wired communication or a wireless communication. What is the difference between your wired communication and wireless communication means? In the wired communication, by using some twisted pair cable, coaxial cable, fiber optical cable, we are going to send the data from the source to the destination. That types of transmission is called as wired transmission. And next comes is your wireless transmission. Without any wire, I am going to migrate the data from a source to a destination. That is called as your wireless communication. You just imagine your Bluetooth. Your Bluetooth Wi-Fi, that is your wireless fidelity, or some of the examples of your wireless communication. So I need a source machine, destination machine, and then a media. Next comes is your protocol. A protocol is nothing but it's a set of rules to govern your network. Is called as a protocol. It is a set of rules which can be used to govern your network is called as a protocol. So we are having so many number of protocols like IP, that is your internet protocol, TCP, that is your transmission control protocol. Next comes is your UDP, that is your user datagram protocol, and Telnet is a protocol, and the SMTP, simple mail transfer protocol, which can be used to transmit your mail from a source to a destination. So these are some of the protocols we are going to use to transmit a data. Generally, the protocol will work behind the screen. And next comes is your media. Next comes is your data, data or message. For example, I'm going to send the data means whether it will be in a format of Word or image or Excel file or your audio file or a video file. So these are the some messages we are going to send from the source machine to the destination machine. Next comes the OSI layer having 7 different types of layer. We are just starting from the lower to the upper layer means. The first comes is your physical layer, data link layer, network layer, the transport layer, session layer, presentation layer, and then your application layer. So these are the 7 different types of layer we are going to see in the open system interconnection or your OSI reference model. So each and every layer will have some unique qualities to send the data from the source to the destination. Each and every layer will have some unique qualities to send the data from the source machine to the destination machine. So we just see the physical layer. A physical layer is nothing but it deals with your raw bits. Raw bits is nothing but your combination of zeros and ones. So in the physical layer, I'm going to transmit a bit from source to the destination. A bits is nothing but it's a combination of zeros and ones. In the case of the physical layer, it will give the services to the next layer, that is your data link layer. So it will transmit your bits from source to destination in the form of zeros and ones by using an addressing called as physical address. By using the physical address, it will send the data from the source to the destination. In the case of the physical layer, if I'm going to send a data called as 1, I just want to confirm whether the destination machine will receive the data called as 1 or 0. So we just want to concentrate whether if I'm going to send a data called as 1, it has to be received as 1 in the destination machine. I just want to check whether it's 1 or it is received as a 0. So these are some of the qualities of your physical layer. This services will be given to the data link layer. That is your next layer. So in the case of your data link layer, which receives the services from the physical layer and gives the services to the next layer, that is your network layer. So it receives the services from the physical layer and gives the services to the next layer, that is your network layer. So what are the main duties of your data link layer means? First comes is your addressing, flow control, error control, packetization, and your media access control. And then your media access control. First comes is your error control. In the case of the physical layer, we are having two different types of errors. One is called as your single bit error, and next one is called as your burst error. What is the difference between your single bit error and your burst error means? First, in the case of your single bit error, for example, I'm going to send a data called as 100 from the source to the destination machine means in the destination machine, I received 101. So there will be a change in only one bit from the source to the destination. I sent 100, but the receiver received 101. So there will be change in your single bit. That is called as your single bit error. That is called as your single bit error. What do you mean by burst error mean? If there is any change more than one bits, that is called as a burst error. For example, I'm going to send a again. I'm going to send a data called as 100, but the destination machine received as 111 means that is called as your burst error. These are some of the two types of error we are having in the case of your data link layer. So we just how we there are two different types of methodology in error control. One is for error detection, and another one is for error correction. What do you mean by error detection means? We just want to detect the error by using some technologies like your CRC, LRC, cyclic redundancy check, longitudinal redundancy check, VRC, that is your vertical redundancy check. By using these types of check, we can detect the error. And Hamming code is a technology. By adding some redundant bit to your source bit or your original data, that is also error detection method. How we can be able to correct the error correction means by using the Hamming code and also using the CSE method, we can be able to correct the errors in the case of your data link layer. Next comes is your flow control. What do you mean by flow control means? So for example, I'm going to send some data from the source machine to the destination machine. First, I just want to check the destination machine memory capacity, whether it is capable of receiving the data from the source machine. First, we have to check. For example, I'm going to send more number of data from the source machine to the destination machine without any acknowledgement received from the receiver machine. I'm sending means the data will not receive the destination machine. For example, I'm going to send some data means I'm sending some data 1. After the receiver machine received the data, it will send a acknowledgement called as ACK0. After sending the ACK0, again I just want to send the data. Likewise, we have to send. If I'm not getting the acknowledgement means the data will get the data will not receive in the will not be received in the case of your receiver machine or the destination machine. So in the case of your flow control, we are having different types of protocols. In the case of your data link layer, that is your stop and wait protocol, go back and ARQ, and then your sliding window protocol. These are some of the protocols we are just using in the case of the data link layer. And next comes is your addressing. What in my addressing means I'm sending the data from the source to the destination machine. by using addressing called as MAC addressing. What do you mean by MAC addressing means? That is called as your media access control addressing. That is called as your media access control addressing. By using the MAC address, I am going to migrate the data from the source machine to the destination machine in the case of your data link layer. So the data link layer, it receives the services from the physical layer and gives the services to the network layer. And next comes is your network layer. So in the case of network layer, it receives the services from the data link layer and gives the services to the transport layer. And it gives the services to the transport layer. So in the case of your physical layer, I am just sending the data. I'm just sending the bits, that is the raw bits, combinations of zeros and ones from the source machine to the destination machine. In the case of your data link layer, a collection of bits, the collection of raw bits, that is called as data frames. I'm going to send from the source to the destination machine by using addressing called as MAC addressing. In the case of your network layer, it receives the services from the data link layer. That is, it receives a collection of frames. A collection of frames is called as tokens or packets. A collection of packets I am sending from the sender machine to the receiver machine by using addressing called as IP addressing. By using addressing called as IP addressing. So by using an IP address, I'm going to send the data packets from the source machine to the destination machine in the case of your network layer. So in the case of a network layer. So what do you mean by packetization? A packetization is a process, is nothing but splitting the larger packets into simpler packets, that is called as your packetization. And then we are another duties is called as a routing in the case of a network layer. What do you mean by routing means? Routing is nothing but I just want to send a packet from a source to the destination machine means from the source to the destination, I'm just having so many number of routes to reach the destination. To reach the destination, the packet will have to travel. So will have so many number of routes to receive the destination. To avoid this situation, I just want to select optimal route, that is the shortest path route to receive the to send the packet from the source to the destination. I just want to need the optimal path and then optimal cost. Optimal path and optimal cost. You just take an example of your traveling salesman problem. You just take an example for your traveling salesman problem. What do you mean by traveling salesman problem? Means a traveling salesman problem is nothing but traveling salesman has to travel n number of cities. You just imagine he has to travel 5 cities. 5 cities. You just want to pick your optimal path, shortest path. By using the shortest path, you just want to visit the cities by using some shortest path algorithm. You just want to in the case of a data structures, we are having Prim's algorithm and then Pascal's algorithm, Dister's algorithm. By using some of the algorithm, we just want to find the shortest path. After getting the shortest path, we just want to visit in your optimal cost. The minimum cost, we just want to travel all the cities. We just want to travel all the cities by a minimal cost, by using a minimal cost. Likewise, in the case of your routing technology, I just want to send a packet in a shortest path in a shortest or optimal cost. What do you mean by cost here means? I just want to the packet will travel from one node to another node. That is called as one hop count. So I just want to travel in a minimum number of hop count. I just want to travel in a minimum number of hop count by using the same shortest path algorithm. And then we are having different routing algorithms called as RIP, that is your routing information protocol. These are some of the protocols we are just using in the case of your routing. So next comes is your internet working. So what is the internet working? You just imagine I'm just running a MNC and having branches in 5 different countries. I'm facing network issues in any one of my country. I just want to troubleshoot the network issues. At that time, I the larger number of network, I just want to split into smaller networks. You just imagine algorithm called as in data structures divide and conquer algorithm. So in the if you take a divide and conquer algorithm means the larger problem will be split into some simpler problems. First, I just want to find the solution for all the simpler problems. Then I can get a solution for the larger problem. First, I just want to find the solution for a simpler. Then I will get the solution for the larger problem. That is the concept of your divide and conquer algorithm. Likewise, in the case of internet working, I just want to split the larger network into simpler networks. After the I'm going to troubleshoot the simpler networks. I just want to troubleshoot all the simpler networks. Then I will troubleshoot where the issue I am facing. That is the main concept of your internet. Next one is your addressing. Addressing here the network layer, the physical layer, I'm using a physical address. In the data link layer, I'm using an address called as MAC addressing. That is a media access controller. In the case of networking, I'm going to use a addressing called as IP addressing. IP addressing is nothing but your internet protocol address. So in the case of your IP, in the case of your IP address, I'm having 5 different types of IP. 5 different types of IP, starting from class A, class B, class C, class D, and class C. Class D is otherwise called as multicast addressing. Multicast addressing. In some MNC, a single system will have many address. That is called as your multicast addressing. Okay. So in the case of your IP address, 5 different types of addressing. The class A will ranges from 0 to 126, right? 0 to 126. Class B will be from 128 to 191, and next one is 192 to 225. Next one is 224 to 255. So the IP will ranges from 0 to 255. The IP will be ranges. Next, in the case of your 120, I'm not using the IP address called as 127.0.0.0. I'm not using the IP called as 127.0.0.0. Why I'm not using this means that is called as your loop back addressing. That is called as your loop back addressing. What is the use of your loop back addressing means it will check whether in my system the TCP IP protocol is installed properly or not. I'm going to check means if in the case of your run or in your command prompt, if you type 127.0.0.0 means it will shows whether your TCP IP protocol will be installed properly or not in your system. That is the main case of your loopback addressing. So these are the some classification of IP address. So where the IP address may be used in is, you just imagine first in the case of your I'm just using a system in my home that is called as your standalone system. If the standalone system, why it is called as a standalone system means it will, the system will not have any address. For example, I need address. For example, I need address means in the case of your address, each and every machine will be connected with the internet, will have a unique IP address. Or if your system will be connected in a network will have a physical address. In the case of your LAN, the system will be connected, will have a physical address. Will have a physical address. In the case of your internet is a combination of two networks. Internet is a combination of two networks. One is your LAN and another one is your WAN. One is your LAN and next one is your WAN. So in the case of your internet, I'm just having two different types of connection of two different types of networks. One is your LAN and another one is your WAN. Each and every machine will be connected with the internet, will have a unique IP address. Will have a unique IP address. That's all about the network layer. Next one is your transport layer. So in the case of your network layer, it will give the services to the transport layer. So in the case of a transport layer, we are going to see about the two different types of protocols. That is your UDP and another one is your TCP. Transmission control protocol and another one is your user datagram protocol. TCP and another one is your UDP. We discuss about the connection oriented protocol. TCP is a connection oriented protocol and UDP will be your connection less protocol. So TCP and then another one is your UDP. So we just want to concentrate in two different types of protocol in the case of a transport layer, in which the network layer will give the services to the transport layer. Two different types. One is your UDP and another one is your TCP. So in the case of your addressing, I already told each and every machine connected with the internet will have a unique IP address. In the case of your, what is the unique IP address means? The IP address will not repeat anywhere in the world. That is called as a unique IP address. For example, what do you mean by address? Each and every machine will have an address. Either it's a physical address or a IP address. If the system is connected in your LAN, it has a physical address. If the system will be connected with the internet, it will have a IP address. So in the case of your address means each and every person will have a address. Likewise, what is the unique IP address means? For example, I'm just having a phone. In that, I'm just having a phone number. You just imagine a 10-digit phone number. That 10-digit phone number will not repeat anywhere in the world. That is called as a unique phone number. Likewise, in the case of your IP address, I'm just having a IP address called as unique IP address. That IP address will not repeat anywhere in the world. That is called as your unique IP address. So in the case of your transport layer, two different types of protocol. One is your TCP and then your UDP. Next comes is your presentation layer. The presentation layer, it will deals with your data encryption and decryption. It deals with your data encryption and decryption. What do you mean by decryption and what do you mean by encryption? In the case of your decryption and encryption means, so I'm just deals with the data. What in the encryption and decryption means, for example, I'm just going to send a data from the source to the destination machine. You just imagine the data will be very secured data. So some authentication we need to send the data. So first what I do means, for example, and I want to save my country. This is my text. This is my text. I'm going to send from the source to the destination. First, I just want to save the country. This will be the original message. This message will be encrypted. This message will be encrypted by using some clipper text or using some algorithm. I'm going to encrypt the text. I'm going to encrypt the text. After that, the receiver will receive the text. Again, he just want to encrypt the, he need the plain text. Then he will decrypt the text using some, I'm going to encrypt the text by using some encryption algorithm and decrypt the text by using some decryption algorithm techniques I'm going to doing. And then it also deals with some data compression and decompression in the case of your presentation layer. Next, the final layer will be your application layer. Application layer deals with some other protocols like your DHCP domain post configuration protocol. POP3 is your email protocol. SMTP, that is your simple mail transfer protocol. This is also your email protocol. Next is your FTP, that is your file transfer protocol. Next one is your HTTP hypertext transfer protocol, and DNS is nothing but your domain name service. So the first comes is your, what is a DNS? For example, you just that is called as a domain name server or domain name service. So you just imagine I just bought a system, got the internet connection. The first time I'm just typing www.google.com. www.google.com. What will happen? It goes to the main server of the Google and fetch the information and load it in your system. It will take some more time. It will take, just imagine, it will take more amount of time. So again, sometimes later, I'm just again typing www.google.com. It will fetches the page very quickly when compared to the previous one. How? So it will goes to your proxy server. It will goes to your proxy server and then fetches the data. So each and every each and every computer will understand only zeros and ones and combination of zeros and ones. We already mentioned in the case of a physical layer also, we the system understand only combination of zeros and ones. I'm typing www.google.com. If I'm typing and then press enter means the IP address of the Google will be found in your left hand side bottom of your screen. You just imagine 198.104.0.1. That you just imagine that is IP of Google. Again, that is called as your the IP decimal IP of your Google, that is called as your partially qualified domain name. Partially qualified domain name. So the computer does not understand your decimal language. Again, it has to be converted into, decimal has to be converted into binary. That is called as your fully qualified domain name. That is called as your fully qualified domain name. These are some of the services we are providing in the case of your DNS. All the website we are using will be saved in the case of your DNS server. And then I'm just using SMTP, that is your simple mail transfer protocol, and POP3 and IMAP. These are some of the protocols we are just using to transmit a mail from your source machine to your destination machine. And next comes is your file transfer protocol and HTTP. These are the some of the services we are just providing in the case of your web browser. So these are some of the layers we just studied in the case of your OSI reference model. In the case of a OSI, we just studied 7 different types of layer. Each and every layer will have some specific function in transmitting of data from the source machine to the destination machine. And the layer will start from the lower layer to the upper layer. The lower layer will be your physical and the upper layer will be your application layer. Each and every layer will have some specific function to send the data from the source to the destination layer. So this is the main theme of your OSI layer, that is your open system interconnection. Open system interconnection. Thank you very much.